we have this circuit, everything that goes through the diode goes to the inductor. So its current is basically similar to this part of the IL. I didn't do a good job. Okay, so this is basically what we have. For the capacitor voltage, we assume that this is, oh, let me first also do the switch. So this part, for the first dt seconds, the switch is closed. So its current, it's going to be 0. Sorry, its voltage is going to be 0. Once this switch is open, we have V in on this part, right? And on the other end, because the diode is conducting, we have 0. So the voltage across the switch, it's going to be V in. Okay, this is T, this is dt. Sorry that the camera moves that much. This, let's do the IQ of T. And the current that goes through the inductor for the first dt seconds, the diode is on, so it's the same as the inductor current. So it's going to be exactly the same as the inductor current. And once the switch is open, it's going to be 0. Okay. Now, I don't have place to do I in, but I in is the same as IQ, right? So this is basically the same. Also, I'm not going to draw VR and IR because we assume that these are constant. Okay, we assume that these are constant. The same for VC, right? So we assume that these are constant. So I'm not going to draw VR, IR, and VC. But let's draw IC. Let me just write down though here. VR and VC are the same as VO. And IR, it's VO divided by R. Okay. We also call this IO, the DC value, right? It has some ripples, but that's why I'm writing the DC here. Okay. Now let's take a look at the capacitor current. The capacitor current, okay, if you look at it, it's always equal to IL minus IR. IL minus IR, okay? So basically, an IR is constant. So if I just subtract this value from IL, I would find IC. Okay, let me just do this. Okay, so this is basically what we end up with. Okay, so now let me, I want to calculate the DC values of some of these parameters. Let's assume that the DC value of IL is here, right? You guys remember that IL DC, right? This has to be exactly in the middle of this triangle, okay? We know that IC is equal to IL minus IR, right? So we shifted IL this much to get here, right? Also, we know that based on amp second rule, that IC average has to be equal to 0, right? So basically means that this point has to be exactly at 0, right? This has to be delta IL divided by 2. This has to be delta IL divided by 2, right? We shifted this delta IL divided by 2, delta IL divided by 2. We shifted this plot this much, right? And this line moved to 0. That basically shows that ILDC for buck converter is exactly equal to IODC or IR, right? So this is equal to VO over R, right? And IC average becomes 0. Okay, so that's the first thing we wanted to do. The average of diode, right? It's basically, if you look at it, this part, it's gonna be, this part is, this line is IL DC, right? The IL average. So if you wanna find the average of the diode current, you can just basically find this area, right? So it's gonna be 1 minus D times ILDC, which is the same as 1 minus D times IO. Okay, I'm just gonna write everything in terms of IO now. IODC, IODC. Okay. The same thing here. This point, because this part is IL, right? So this middle point is ILDC, right? If you want to calculate the area of this shape, it's basically the same as the area of this rectangle. So IQDC, it's going to be equal to D times ILDC, which is the same as D times IODC. Okay, so we did the calculation for the average values here. Maybe we'll do it here just as a practice as well. VLDC based on volt second balance is equal to 0. That's how we calculated the duty cycle, right? You can do the calculation for these ones as well. That's not that difficult. Like VQ average here, for example, it's gonna be this area, which is D times V in, and VD average, it's equal to, sorry, this was 1 minus D, because this is 1 minus D times T times V in divided by T, right? So in this one, it's going to be negative D times V in. Okay, so we calculated the average or DC values of all of these parameters. Okay, the part, because we want to calculate power, one thing that becomes very important here is calculating the RMS values. That's why, like, I spend a little bit of time explaining the RMS value. So we actually, let's just start with this one, right? We already did the RMS value of this, right?